All right, so let's take a look here. So if we are looking at number 9 here, it says an exponential function of the form. So we're used to f of x equals a times b of x, but it's saying f of x equals b to the x. So that just means that our a value is already a 1, so you don't have to worry about it. So all we have to do is just worry about the b value. And remember, we learned the other day that the b value is just a common ratio. So basically what you're doing is you're looking at, these are consecutive numbers, so 2, 3, 4. So let's look at the output 16, 64, and 256. Okay, so that's 16, that's 64, and 256. And what is it that we're doing to get from one to the other? We know it's exponential, so what is it that we're multiplying by? What are we multiplying by? From 16 to 64 to 256. Well, if you're ever unsure, you can just open a Desmos tab and divide one of the numbers by the previous one. Okay, so let's take a look. So I'm going to take 64 and divide it by 16. Okay, so, oops. So 64 divided by 16, I get 4. Or we can go back and do 256 divided by 64. So 256 divided by 64, and I still get 4. I get the same thing. All right, that's what the common ratio is. So we're multiplying by 4, multiplying by 4. And remember, our b value is that number. So really my function is just f of x equals 4 raised to the x. There it is. It was that easy. We didn't need an a value because it already tells us that there is no a value because my a value is 1. Okay, number 11, we've already talked about a problem like that. We actually I think we even did this exact same problem, but you should know the error. Okay, so let's say the starting value is 6, right? So we're saying f of x equals a times b to the x. Well, the starting value is 6, and my constant or common ratio is 1/3 to the x. And then all of a sudden they bring it down to 2 to the x. Now they did something wrong here. Something that they did wrong. What did they do wrong? All right, so describe that. And then you're graphing here. Okay, so what you can do when you're graphing is just create your own table, right? And start from -2, -1, 0, 1, and 2. So you can start from there and just find the y values for each of those. It shouldn't be that hard. Okay, and then graph it, and you should know sort of the shape of it, knowing that this is our b value is greater than 1 and this b value is between 0 and 1. You should already know ahead of time what the shape of it is, and you should already know if it's growth or decay. Okay, key features, we talked about these. Okay, you should know the y-intercept, the asymptote for us never changes, and remember you look at the b value to determine if it's increasing or decreasing. Okay, so if I did 17, well, remember the a value is my y-intercept, so there's no a here, but there actually is, and it's a hidden 1, so the y-intercept is 0, 1. The asymptote does not change. Y equals 0. Okay, for this section, it's going to be y equals 0. And then this one here, this b value is in between 0 and 1. It's less than 1. So we know that it is going to be a decay or it's going to be decreasing. Okay, and if we look at number 19, right? So the a value is the y-intercept. So that's going to be 0, 2. asymptote doesn't change. It's y equals 0. And then we want to know if it's increasing or decreasing. We look at the b value. We look at that one right there. That's the b value. And that b value is bigger than 1. So that means it's going to be a growth, right? Growth is this one. It's like this. But decay looks like this. That one's going to look like this. That's why it's decreasing. This one is increasing. Okay? So on 21 and 22, right, we're going to use the generic formula, y or f of x equals a times b to the x. So remember, a is my initial value and b is my base, or it's also the constant ratio, the common constant ratio. So let's find a. Well, a is when your x value is 0. So here my x value is 0. So this actually represents the coordinate 0, 4, which is on the y-axis. So my a value I know is 4. Then I need my b value. So I need my b value, and then I'll raise it to the x. So my b value is what am I doing to get from one number to the next, one number to the next. So let's see here. What am I multiplying by from here to here, which is the same from here to here, which is the same from here to here. Okay. Well, it looks like maybe you might think you're multiplying by 3 because you got 3, 9, 27, 81. But actually what you're really doing is you're dividing by 3, right? You're dividing by 3. But dividing by 3 is really multiplying by 1/3. That's what dividing by 3 is. So that's multiplying by 1/3. But let's check my trick. Remember I told you guys to go to Desmos? So I'm going to do 4/3 divided by 4. So let's see here. I'm going to do, so I'm going to do division. So I'm going to do 4 divided by 3. Oops, divided by 3. Remember, so I'm going to take this one and divide the previous one. So 4/3 divided by 4, and I get 0.3333, but as a fraction, that's 1/3. Okay, let's try a different one. Let's try another 2 consecutive ones. So I'll do 4/27 divided by 4/9. So I'm taking one of them and dividing by the previous one. This works every time. So 4/27 divided by 4/9. Okay. And I get 1/3 again. Okay, so I know I'm multiplying, or my common ratio is 1/3. So I put a 1/3 in, and that's my function. So f of x equals a, which is 4, that's my initial value, times my base, or constant common ratio of 1/3. And there we have it. All right, enjoy.